Hey there, and welcome to another channel review. Today I have to present a new product sent by Abestop in a new channel collaboration. I have to confess that I didn't know Abestop before, but when they contact me to present this new AT312G 3-in-1 device, my curiosity popped up. Lately, these 3-in-1 devices shown that there is a market for them, and there are some with a lot of success among the users. So why not see what they have created and do my normal battery of tests. Just give me a moment to tell you as a disclaimer that this device was sent to me for review free of charge by Abestop, but no money was paid by them to produce this video, and they will see it at the same time you will. I thank you for Abestop for sending this device that allow me to do this review and present it to you, but also a big thanks to you, my viewer, that sponsor the channel just by using the affiliate links on the screen whenever you go shopping on AliExpress or Amazon. You pay exactly the same to the cent, but by using these links for your purchases, you are sponsoring the channel and giving me a big help to keep making these videos. So a big thank you. Without further ado, let me show you the key features. So let's start by seeing what is in the box. It comes in this retail box, a few informations on the back about the technical specifications. Okay, let's open it. Okay, it is delivered in this bag. Let's see what comes in it. We have a simple instructions diagram in English and German, a user manual in English, seems very well organized, a user manual in German also, a pair of alligator clips adapter, USB Type-C to Type-A charging cable, a pair of test leads. They seem pretty standard. Yeah, a little stiff. And finally, the oscilloscope, multimeter and function generator. Let's open it. Yeah, here it is. As first impressions, it seems to have a very nice construction. All these parts in the sides is not rubber, but it's a plastic that will give you a very good grip. It will not allow you the multimeter to slip easily. Okay, we have on the left side this socket for connection to the power supply. I don't know if you can download the image to the PC. I will check that out. Also in the back we have this stand, as this normal stand. The position seems okay. It's very nice to position to see what is on the screen. But you also have this one, this higher one, that I'm guessing that I will use it a lot to do the review. Okay, and in terms of options, we have these buttons. They are, yeah, almost rubber. They seem nice while pressing it. Yeah, the knob has some pressure in it. Seems okay. If you notice in the bottom you have the normal 4 connectors. We have in yellow, in this red connector, the oscilloscope indication. You should use it with the COM, and we have also here the output from the waveform generator. Okay, a red button to control the light. It has this rectangle, but I don't see anywhere NCV is just decoration. Yeah. So yeah, let's power this up. Okay, we have some light in here. Yeah, let's and this is quite gaming. It changed the light as you go. Okay, it will give you an idea of different values. Okay, nice. Very nice. It's a cool detail. Nothing special, but it's a cool detail. Okay, and this button will allow you to change the color of this, well, not the color, the light of the screen. Okay, so let's see how this works. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Okay, to show you how this works, I'm using an adapter. Yeah, this is an adapter from Banana Clips to BNC, connected directly to my function generator, and I'm outputting on the function generator right now 100 kilohertz sine wave. The sine wave is shown on the screen. It's pretty steady, no jitter, at least at this speed. And we have here on the screen, let me show you. So from the top left to the bottom, we have here the coupling mode, also the time division and the amplitude division. We have the rising edge in this, the slope. We can change it also. The mode of the trigger right now is triggering, and the battery indicator. So in the screen we have the sine wave with the indicator of the position of the sine wave on the left and the trigger level on the right. In the bottom we have some information like the VPP. I'm right now outputting a 5-volt VPP signal, so 4.84, it's good. We have the millivolts average and also the voltage VRMS, and finally 100 kilohertz frequency, so it's pretty accurate. We have in the bottom the menu for several operations, like let's see, we can change the time division by pressing F1 and then using F2 and F3 to change it. Again, F1 will leave the screen. We have the voltage or amplitude division. We can increase or decrease. Exit. We can also change in the F3 menu. Let's go back. In this one, the trigger, it's the F3. The rising or falling edge. Right now it's falling, rising edge. Also the trigger modes, single, normal, and auto. And the F4 will allow you to change, let's see, the trigger level. If you press it, you can see this small arrow. Yeah, it should work, keeping pressing. So you have to press a lot to get there, but it's changing the trigger level. Okay, exit. Let me show you here auto. It's what it says, no more, no less. And it's fast to do the auto operation. And we have also the save button. If I press save once, like so, okay, this image will be saved. Well, it stops, but if you press for 2 seconds, you enter the record position 1. We have 10 positions, if I'm not wrong. And you can press again F4, like this, and this sine wave is saved on position 1. We can erase it or browse through the several positions. As you can see, everything is blank right now. Okay. Save again for 2 seconds, and you are back. So the save also works as stop, run, stop, just with a quick position. One final note: to work on the oscilloscope modes, you will have to put on voltage in the knob and press for 2 seconds the auto button, like this. Yeah. Okay, in terms of oscilloscope, that's it. Let's move to the multimeter. Okay, so when you power the multimeter, for default, he enters in multimeter mode, and that's okay. As I shown before, you just press for 2 seconds auto, it will change to oscilloscope, and auto again, it will change to multimeter. In multimeter mode, you have several options, so voltage, millivolts, this is resistance, diode, and continuity, capacitance, frequency, microamps, milliamps, 10 amps, and you can turn it off by moving to the bottom options on the left or on the right, like this. Whenever you change an option, it will create a new color, and that's a nice detail. It's a pretty gamer options like this, and you will have several colors depending on which option you are using. This is nice. Maybe it will help you to understand which kind of measurement you are doing immediately. But yeah, so in the screen you have the battery indicator as normal, you have the voltage, that is the measurement that we have right now, the range, and obviously the information, the DC and millivolts. In the menu you have relative, pH, the minimum and maximum. You enter this menu where you can stop the measurement or run it or restore it. You have exit also. Okay, and you have also the select button that will allow you to browse several functions. Let's see what we have. We have auto with AC and millivolts right now because I'm not injecting any signal into this. We have the frequency also in here. Again, the frequency in percentage. That's weird because we have here this knob to select that, but okay. And we are back to voltage. So in the last option of the menu we have range, where you can change the range. Right now it's DC manual instead of auto. And we have several ranges going up to 1000 volts DC. Okay. So if I select also AC, we can change the range the same way. Let's see what is the biggest range. Okay, we are in 1000 volts DC, AC right now. Okay, that's cool. I find this a bit odd. So if we have frequency in here, why do we have this hertz? So it seems the same. Yeah. Okay. It will do the same. So we have millivolts with the same options basically, and also resistance. And to change this, use the select option, diode and continuity, the relative option and the P old with the max minimum always on the screen. So it's a nice detail, I like it. We have the capacitance, we only have one option. Okay. We have the frequency as we saw before, microamps, same options as before, and this should be all the same what we have in select. It will not change anything. And 10 amps maximum. Okay, that's it in terms of multimeter, and I will test it in a bit. So finally, in terms of operation, we have something that is operated by this red button. If you press the red button once, it will change the intensity of the screen. I have it in the lowest so we can see well with the camera what is going on, but if you press it by 2 seconds, like this, it will enter the waveform generator. This is a very simple waveform generator. Right now is outputting. It will tell you that it is generating a square wave with a frequency of 1 kHz, duty cycle of 50%, and the output voltage of 3 volts VPP. So you have, in terms of signals, the sine wave, and we can, as always, change it using these F2 and F3 keys. You can change to a sine wave, for example. Okay, in terms of frequency, it's fixed. You can go several values up to 100 kilohertz. And okay, in terms of voltage output, you have a maximum of 3 volts VPP with several values up to, well, 0 volts VPP or 0.1 volts VPP. Exit. Let me check if the values are the same for, yeah, they are the same for square wave, and yeah, all equal in terms of output. This will be tested more ahead in the video. One last thing to show is that auto will put the output on or off, and finally, to use the waveform generator, you have to connect it here on the output. Okay, so oscilloscope in the red, function generator or waveform generator in the yellow. Okay, that's it. Let's start testing. To test the bandwidth, I'm going to use these adapters to connect to my function generator that is already in the screen, as you can see. So this is a 12 megahertz oscilloscope with 50 megasamples per second sampling rate. And I believe the minimum for 12 megahertz is 500 millivolts division, but if you go up only up to 8 megahertz, you can do 50 millivolts per division. Okay, so let's start testing. I right now have 100 kilohertz on the screen. Let's do an auto. Okay, seems okay. It detects the 5 volts VPP, and I want to change that for 1 volt. Give me 1 second so we know the true, oops, not this, amplitude. 1 volt VPP, and in frequency let's start with 100 kilohertz. Okay, so why do I want 1 volt VPP? I want this voltage because if this goes below, let's say it's 720 millivolts, something around that, it means that it will be below the minus 3 dB. So it seems that it will not have the full bandwidth that is telling us. So let's start with 100 kilohertz. I'm moving up to 1 megahertz. Okay, auto. On 1 megahertz it detects very nicely. We have a VPP of 960, so we are good still. Let's increase here the time division. Yeah, it's okay. It's a very nice square wave. Okay, not too much jitter, but this is a bit slow. So right now we are in 500 millivolts. Let's see if we can bring this down. No, we cannot. Okay, so moving on, and I will do this manually. Okay, 2 megahertz, 3, 4, 5, 6, 7, 8, 10 megahertz. Okay, let's do an auto. On 10 megahertz we have the VPP over 1 volt. This is a red flag. Let's see, let's move it to 12 megahertz, the maximum reported of this device. Okay, and something happened here. Okay, let's increase. Okay. This is as low as we can go, 200 nanoseconds with 12 megahertz. We still see the sine wave. The VPP is over 1 volt. This is a bit suspicious, but since we are at the maximum megahertz, it should be near or below 1 volt. That is the VPP that I'm outputting. It identifies the 12 megahertz pretty well. No issues here. I will give it a thumbs up. Everything seems to be working. I'm quite suspicious with this value, to be honest. Let's do an auto again. Yeah. Okay, the time division has to be decreased again. Okay. Let's see until when we can go. I'm at 15 megahertz right now, auto. But it will not detect here the 15 megahertz, so it doesn't matter. Yeah. I will say it's a pass, but even so, probably we'll trust this until 8 megahertz more or less. Let's now see how about 100 kilohertz square wave. Okay, not bad at all. Okay, let's pass this to 1 megahertz. Auto. Okay, so in 1 megahertz I still have weird values here in the VPP, but yeah. Okay, 1 megahertz we start to see some problems, some alterations in the signal. Okay, I will move this manually to 2 megahertz. 3, yeah, it doesn't matter to go over this because the signal is already quite, well, this form. Okay, nice. Just to finish a ramp. Okay, 3 megahertz ramp. We have a drop to 940 millivolts. Yeah, a little jiggling in the screen, but okay, good enough. I think that's it for bandwidth testing. Let's move on. To test the DC measurement, I will use, as usual, my DC voltage calibrator. I'm already outputting signals. Let's put this at 0. As always, and if you see my channel, you know that I always test it also comparing to my Siglent STM3045X. It is pretty accurate. And let's start. 1 volt. Okay, 2 volts, 3 volts, okay, pretty good, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts, pretty near, 9 volts, and back to 0. Okay, let's start in the millivolts range. Okay, 100 millivolts, and we can do it also in this one. So 100 millivolts, 200, 300, okay, pretty near, 400 millivolts, 600, 500, 600, 700, okay, it's out of range. I have to go back. Yeah, spot on. 800, 900, and we are back to zero again. Moving to millivolts because we are going down. Now we are on the 10 millivolts range. Okay, 10 millivolts, 20, 30, 40, 50, 60, 70, 80, 90, pretty good, and back to zero again. Okay, we are now reaching the 1 millivolt range, and this is where things start to get hard. Okay, 1 millivolt, it's a bit over, 2 millivolts, okay, but at least the value is consistent. Okay, as you see, 3 millivolts, 4 millivolts, 5 is always above the less significant digits, 6 digits above, 6, 7, 8, 9, and 10, that it's 0. Again, as you can see, even with 0, we have already 0.5 millivolts over, so it's pretty consistent going there. I will now enter the microvolt range. I don't know if it will be able to detect. Yeah, still the 5 digits over, but it's going there. 20, 30, 40, and I'm pretty happy with this. This is being able to see the microvolts. It's pretty accurate. 50, 60, 70, 80, 90, and we are back to 0. So it was able to see all the ranges. We have a small issue with these 5 millivolts. Let's try again. It was jumping a bit. Yeah, still there. But pretty happy with this. Let's move on. To test the AC voltage measuring, I have my Siglent already measuring the mains of my house with this in this socket. Let's start by inserting the command, and now be careful because this is high voltage. Let's see what we have in here. Oops. Okay. So it's measuring 235-36 volts, and that is totally in line with what we have in the Siglent. So another pass. Very nice. Now let's test the frequency. I have my function generator already outputting 1 megahertz. It seems to detect fairly well. Also the duty cycle. Yeah. Okay. So let me now increase the frequency and see how much frequency we can measure with this. Okay, 3 volts, not volts, 3 megahertz, 4, 5. Let's take it to 10 megahertz. Okay. Now let's take it to 15. Yeah, 15 megahertz. Spot on, no issue there. Let's continue. 20. 30 megahertz, yeah, pretty nice. 40 megahertz, still spot on. Let's do the duty cycle, 50%, perfect. Okay, moving to 50 megahertz. Okay, 50 megahertz. Duty cycle is a little off, but yeah, still good. Okay, and yeah, okay, 56, 55, 54 megahertz. Okay, I'm using a VPP of 5 volts. This is 40%, 48% duty cycle at 54 megahertz. Okay, 55, it will stop measuring. Okay, I went to see in the manual, so the frequency says it's up to 20 megahertz with 2 volts VPP, over 2 volts VPP. So yeah, we are good. We are good. More than 20 megahertz is for reference only. So okay, that's honest. By me, it's a pass. Let's move on. For testing the milliwatts measurement, I have here my FNIRSI SG004A. It is a signal generator that will produce current until 24 milliamps, and we will be able to measure it using the Abestop AT312G. Okay, let's start. I will open the channel and I will start with 1 milliamp. So 1 milliamp. Let's take it to 5 milliamps, spot on. 10. Okay, 1 digit off, still good. 15 milliamps, 1 digit off. And 20 milliamps, still 1 digit off. I will now take it to 24 milliamps, is the maximum, and still spot on also. But one thing that is interesting in this device is that we have also the microamp. So to test that, I will move to the microamp range and I will start testing it now. Let's see, 10, okay, 20. It seems that we have a small difference there. Okay, I will activate the rel. Will activate. Yeah. Okay, now this off and let's try again. So yeah, it seems that it is good because on 0 we have -1. Yeah. Let's try again. 9.5, 19, almost 20, 30, 40, 50. Yeah, so we are using microamps right now and it's fairly accurate. Very nice. This will be great in terms of electronics solutions. So 300 microamps, yeah, 400, 500. Yeah, these are very, it is able to go until 600 microamps. After that we have to change to the microamps range. But pretty happy with this. So, okay, let's move on. For resistance testing, I will use the supplied test leads. Okay, they are good enough to do the job. Cat3 1000 volts, 10 amps. Okay, so let's start with the first value. It should be by reference 10 ohms. Okay, almost spot on. The second is 100 ohms, almost spot on. 103, so we have 101. Yeah. The next one, it will be 1K, 1.0003K. Okay, let's see what we have. Fair enough, spot on for me. Next is 9.995K. Okay, 9.99, also good. 100.06K. And let's see what we have. 100. Okay. Seems really good. Almost spot on in everything. Still with the same test board. This is 1%, 25 parts per million precision resistor reference. Let's start to test the capacitance. Okay, let's move this to capacitance and we will test it with this board. Okay, the first value is 102 picofarads. Not all the devices can go to this range, and he detected 148. Yeah, okay. The next one is 1.02 nanofarads. Okay, 1.078 or 08 rounding. The next one is 10.4 nanofarads. Let's see what we got. 10.44, yeah, spot on. And we have 95.7 nanofarads. Okay, very near, very satisfied with it. This one is always wrong in these measurements, or at least it's not in conformance with the value. It should be 800 and something, near 900, 874. Even if it's not in line with the value here, it's in line with the previous measurements I made with other multimeters. So yeah, also good. And we have 10 nanofarads at last. Let's see. Okay, 10.5. Okay, a pass in capacitance also. For diode testing, I have here the usual suspects, the 4 diodes that I use for testing. Let's start with this one. And okay, a gain of 777. It's in line with the previous measurements I made. This should be 1.6, 1.7 volts. Yeah, it has the light on, pretty bright, very good. This is also 1.7, but a different size. Yeah, okay. And finally, I have this one that should be a 2 something, 2.6, I believe, 2.6. Yeah, also good. It's a white diode. Very nice. Let's go on. Okay, now it's the test for continuity. Let's see how much time it takes to produce a sound and to update the screen. Yeah, it's quite fast to produce a sound. The screen update takes about 1 second. Yeah. Okay, very nice. And we have a light also that is quite fast to respond. It responds at the same speed of the sound. Okay, I think it's a pass also. Very fast to respond. For the waveform generator, as I showed before, you just need to press this red button for 2 seconds and this interface will appear. We can select the signal, that is generator. I will start with the sine. Let me exit. Right now it's a frequency of 1 kilohertz, that is cycle 50%, voltage 3 volts VPP. I will activate with the auto. You can see it already in my function generator. Quite stable, the signal. I will increase the frequency. Let's see. Let's go to the maximum. Okay, to see how it handles. Okay, I will need now to do auto in my oscilloscope. Well, the line is okay, no worries about it. Let's see if we can change the duty cycle in sine wave. We shouldn't. Yeah, it doesn't do anything. So it shouldn't allow us to do that. And if we go to square wave, 50 kilohertz sine wave, I don't think that we can go up than that for the square wave. And yeah, that's what we got. Let me do a auto again. It has a little, yeah, in the maximum it has a little round corners on the bottom and on the top left side. But let's see if the exit and if the duty cycle now changes. Exit. We have to exit. It's not like in here, if we change it, it automatically updates. But on the on the duty cycle, it will not. So let's try again on the sine wave. Yeah, I will exit now. Yeah, nothing happens, as it should not. So square wave. Okay, let me put a lower frequency, like 10 kilohertz. Okay. And do again. Yeah, the square wave is not quite perfect, but it seems to do the job. Okay, duty cycle changed. So for most of the cases, this will do. Okay. And finally, we have the ramp. Let's see what we have on the ramp. Okay, pretty perfect signal. Okay, it's not the best waveform generator that I saw in one of these devices, but yeah, it will do the job, I think. To wrap it up, I would like to say that this small fellow was a nice surprise. For the price and features, seems to be a nice choice. But I'm a bit sad it's not being sold on AliExpress, only Amazon and their website. This means that this brand, Abestop, does have a website where you can request support if needed. But getting to the price, it is being sold on their website for $70 to $99, and that is around 66 euros, give or take. When I first looked at the price, it looked to me that it could be a little more competitive, but only after a quick look in AliExpress for 3-in-1 oscilloscope or multimeters, I quickly found out the price is more or less in line with the similar devices. One positive difference to note is that the AT312G brings the microamps measurement to the table, not normally seen in devices of this price range, so good news for that. The multimeter is very accurate and with precise measurements, the ranges are good enough and very easy to work. This is a personal opinion, but in portable multimeters, I still prefer the ones that use the knob, this one, to select what you want. The oscilloscope is not the best I saw in one of these devices, but works well. The only thing I got a little suspicious was with the VPP over 1 volt on the bandwidth tested to 12 MHz. Normally, on these economic 3-in-1 devices, at the maximum bandwidth you are near or many times below the -3 dB. That with 1 volt VPP should be around 700 millivolts, but rarely over. So, but the waveform was okay and the oscilloscope did its job. The waveform generator is enough for most of the people, but let me note that the square wave at the maximum output had a bit of round corners on the left side. The rest of the signals were okay. In general, the waveform generator is in line with the equipment. Works well, not too fancy, but get the job done. This 3-in-1 AT312G has some strong points and not many weak ones, so it's one more option in this category of multipurpose devices. If you are considering to buy one of these Abestop AT312G devices, please consider also sponsoring the channel. It's really easy, you just have to use one of the affiliate access links on the screen whenever you visit AliExpress or Amazon for your purchases. You pay exactly the same, but you are giving me and the channel a big help to keep these videos coming. And please remember, if this video was in any way useful to you, please slap that like button to help the channel grow. And if you want to keep up with the new equipment that arrives to the market, hit that subscribe button also, because every week I receive new material to review. That's it for today. I really appreciate your company and the time you spend watching this video. I hope to see you again in my next one. Until then, take care.